Hello everyone, welcome to today's project demonstration where we will be testing the capacity of a 12-volt lead-acid battery. In this video, we'll walk through what the project does, explain the components involved, and delve into the circuitry. We'll also understand the working principle and analyze the Arduino code that powers it all. Sometimes it is necessary to check the battery level. When you buy a new laptop and with a full charge the laptop lasts half a day, and with time the laptop doesn't last as long. It's because battery degradation, and that's because the battery over time cannot hold as much charge. So we need to check the capacity of the battery as it degrades. So this project checks the capacity in battery and displays the final ampere hour capacity, and it also logs the data on an Excel sheet. So I'm going to explain now how the project works. So first, let's start the project, and I will explain along the way how the project works. So as you can see, once I connect it to the battery, first it detects the battery level, and if the battery is not fully charged, it's gonna show the battery not fully charged. So I'll come back with a recharged battery. Now back with the fully charged battery. If I plug it, as you can see here, so initializing and the battery level is okay. So if the battery level is over 12.5 volts, it's gonna start draining the battery. So it's gonna take a while. So let's see how the data streaming works. Here on this computer, I just connected this Arduino via the USB port, and on this computer you open Excel, and in the data streamer tab, select the device Arduino Uno, and then once you start data is gonna come in. So this is the battery voltage level, and if I select all of these cells, like this, and start recording data, at the end I will end up with a battery voltage curve as well once I plot those data. And with this I can also plot the data. If I use point graph, the data will be plotted. So right now the battery is at 12.3 volts, and the voltage, it fluctuates a little bit, so that's why you're saying it fluctuates around around 0.2, 0.3 volt, as you can see here. Let me first explain the components that is required for that project. So the first component you can see here is the voltage sensor. So the voltage sensor is this sensor, and it detects the voltage across these two terminals. So if you put the positive terminal here and the negative terminals here, you will sense it. The voltage sensor will sense the voltage. So it utilizes a voltage divider system and brings the output at the middle of the voltage divider system as a voltage range from 0 to 5 volt. The circuit schematic, the interfacing is as shown. So the ground and the VCC is connected to the positive and negative terminal of the battery, and the negative is connected to the ground of the Arduino. And usually you don't have to connect the positive because it is powered from the battery. And you connect the data pin to any of the analog input pins of the Arduino. So in our case, we have connected the the voltage sensor data pin to analog input 2. Like I said, the voltage sensor outputs a voltage value from 0 to 5 volt depending on the input voltage, and the input voltage range is 0 volt. It's actually not 0 volt, it is the lower limit of the input voltage is 0.02445 volt, and it goes all the way up to 25 volt. And you'll see now in a second why I added the 0.06 volt voltage here. So it basically, I take the voltage sensor input, which is connected to the analog pin, as a value between 0 to 1023, and this map float function, it converts the value to the desired voltage. The map float function works similar to the map function. It's just the float is function. The map float utilizes floating point values instead of integer values. And here I added 0.06 because the terminal voltage drop at the alligator clip is this voltage. So after trial and error and figuring out the voltage level, I came up with this number. Let's see how the map float function works. So this is our map float function. So it takes the voltage input and the input minimum. So this is the input and this is the input maximum. So this is the input minimum input the voltage sensor is gonna send to the Arduino, and this is the maximum input the voltage sensor is gonna send to the Arduino, so which is 0 and 1023. And float this out minimum is the 0 or the 0.02445 volt, and out max is 25 volt. So it's gonna return, depending on the input, a value in voltage which is in between 0 and 25 volt. Now the current sensor. The current sensor, you put the current sensor in series with your load, and with Hall effect the sensor measures the current flowing through the sensor. So this is the schematic of the interfacing with Arduino. You put the positive in one prong, and then it goes out and goes to your load. So in our case, the load is the Arduino, the fan, and most importantly, last but not least, the 8 ohm resistor that drains the battery. So any current that comes out to the battery is recorded through the current sensor here. So, and interfacing with Arduino, the VCC goes to 5 volt, the ground goes to the ground, and Vout goes to a analog input of the Arduino. In our case is analog 3. Let's now see how the current sensor input works. So this function, it converts the current sensor input, which is a range from 0 to 1023, to an output, and the higher limit of the current sensor is 5 amp. So the maximum it could go is 5 amp. And from the datasheet, the current sensor, it can only, when the current value is 0, the current sensor, when the current value is 0, the current sensor sends 2.5 volt through its data out pin. So the lower threshold is 2.5 volt, and from the datasheet the resolution is 0.185, and at the end the function returns the current. So this function has been taken from the datasheet of the current sensor. And here in the loop, we just utilize that function to get the current sensor. And so the I sensor value is the analog read of the pin that the current sensor is connected to, and if we've run it through the function, car sense function, and they will give us the current value. Now the relay. So the relay has a ground pin, a normally open pin, and a normally closed pin. So what the normally open and the normally closed means is that when you send 0 volt to the data rail, the current, the relay will be open or closed. Say if this is a normally open pin, if you send 0 volt or no volt through the data pin of the relay, normally open means this circuit will be open. But if we connected instead of here, if we connected here and send 0 volt, in that case the circuit will be closed, so current will flow through the circuit. And for interfacing, we just connected the ground to ground, 5 volt to 5 volt, and a data pin to a digital pin, so the Arduino can send 5 volt or 0 volt. So in short, when the Arduino sends 5 volt and your load is connected with normally open, that means your circuit is closed and the current will flow through. And when the Arduino sends 5 volt and the load is connected to the normally closed, the circuit will be open and no current will flow through. Now here I have used a 8 ohm 50 watt high power resistor as my battery draining circuit, so the battery can drain fast and we wouldn't have to wait as much time, but still it takes around 2.5 hours to fully drain the battery, and it is done for accuracy as well as functionality in mind. Also, a cooling fan and a heatsink has been used to cool down the resistor sufficiently so it's safe to touch. So the operating temperature does not exceed more than the room temperature, so it stays around at room temperature because of the cooling function. Now I'm going to explain the project using the system block diagram. So this is the 12 volt 7.1 amp hour lead acid battery, and this is its positive rail and this is negative rail. Now the relay here is connected as normally closed, so when you don't send any voltage through the data rail of the relay, it's closed, so the current will flow through. But once you send 5 volt, the relay will close and relay will open and no current will flow through. This has been implemented because so the battery doesn't drain below its critical level, and basically all the load from the battery is cut off and the Arduino will only be powered from the PC. Here we have the voltage sensor. The voltage sensor senses the voltage sensor here is connected across the battery terminals, so it can detect sufficient voltage. And for the voltage sensor, there is a voltage drop at the alligator clip and there is a voltage drop at the relay. although when the relay is closed, the voltage drop isn't too much, but it has been taken into account in the code, so accurate measurement can be achieved. Now the current sensor. So as you can see, the current for all the load goes through the current sensor except for the voltage sensor. The voltage sensor draws really small current which can be neglected, and still we end up with a very accurate result. So the current sensor, the current comes in and it goes out through this rail, and this is the data pin. The data pin, the voltage the current sensor throws out to the Arduino in order to depending on the current through the current sensor. So all the current goes through the circuit, goes through the current sensor. So as you can see here, the current comes from here, goes through here, is connected in series. Just a small current, it goes here, which is not detected from the current sensor, but the current is so small that it doesn't matter. And it goes through the current sensor, and then it goes to the Arduino, powering the Arduino, and it goes to the cooling fan and the resistor, which draws the most current. And also the Arduino, it displays the current, the voltage, and the current ampere hour reading to the LCD display, and it also streams out data to PC to log on Excel. So as you might have noticed, there is another relay here which is normally open. So what the Arduino does is senses the voltage first. If the voltage is below a certain level, which is 12.5, that means the battery is not fully charged. So the Arduino, as we just saw in the beginning, the display will show that the battery is not fully charged. Only when the battery is fully charged, then the Arduino will send 5 volt through its data rail, and the relay will close and the battery will start discharging. Then the data will start will stream to the PC and the Excel as well. So one component that I've missed is the LCD display. So the LCD display has a bunch of pins labeled as RS, E, and D 4, 5, 6, 7, RW, VSS, VCC, LD plus and L minus. So you connect those pins to the corresponding pins of Arduino, like so here, and also you have to put a potentiometer for fine-tuning the contrast of the display. So here is the schematic of interfacing a display with Arduino. So I'm not going to go too much detail into it, and I'm just going to go into the code to explain how the project works. So starting from the top, this is the floating function that converts the voltage sensor input to a readable voltage output. This converts the current sensor input to a readable current output. And this is the library you need to include to run your LCD display. And this is basically saying to the LCD that RS is connected to pin 12, EN connected to pin 11, and D4 to D4 to digital 4, D5 to digital 4. So as you can see here, D4 is connected to pin 5 and D5 connected to pin 4, but it doesn't matter because I must have swapped it here, but it doesn't matter because these are two digital pins, and it's just utilizing those digital pin for two levels of communication. And here I have swapped it because so that doesn't make any difference, as the code as a display is running, so that means the code is fine. And as you can see here, the voltage sensor is connected to analog pin 3, the current sensor is connected to analog pin 2, and these are all the variables that I had to declare in order to measure the values. And the relay 2 is connected to digital pin 10, and the relay 1 connected to digital pin 9. Now, I have set the relay state to high. I'm going to explain it a little bit later why I did it as I go through the algorithm. And the V threshold is the battery voltage where all the current from the battery is cut off. The battery draining circuit is cut off, so the battery doesn't drain too much. And this is the voltage sensor lower limit, and this is the capacity that we're looking for, and it will be incremented every second. The millis function gives you the time in millisecond since the code starts running. So I'm going to explain how it works. Now here I set pin 10 as an output, which is going to give the relay the signals that it needs. And I initiated the serial communication at 9600 baud rate, so we could communicate with the Excel sheet and stream data to it. And I just began the LCD. It's saying it's 16 rows and 2 columns on the LCD, and I set the cursor on the LCD, and I just put the message initializing, and so once you start the machine, it's gonna start by saying initializing, and then it's gonna take the voltage input from the voltage sensor, and then it's gonna convert it to the voltage value. So here, if the voltage value is over 12.5 volt, that means the battery is sufficiently charged, and that means the battery is sufficiently charged, and also it has to be less than 14.5 volt. This has been implemented to save it from overcurrent. So the overcurrent protection in the brochure means if a battery with really higher voltage is connected, the relay, as we will see, will be open, and no current will flow through any of the components. So it is implemented for higher voltage and high current safety. And if these two conditions are fulfilled, then the battery level is okay, and it's going to exit and start here. So I'm going to explain it a little bit later, and let's explain the next one. So if that doesn't satisfy, then it's going to go into the else section, and if the voltage value is over 4.5 volt, then it's just going to display high voltage detected, and it's just going to be on a loop at this point, so nothing happens. Also, if this is false but only this is true, that means the battery is not sufficiently charged. So when the battery is not sufficiently charged, that means the battery level is below 12.5 volt. It's going to say the battery is not fully charged, and it's going to be on a loop here. Now, if the battery is fully charged and the battery does not and we did not connect a battery with very high voltage, then it's gonna start the relay. So the relay set, remember we set it to high, so it's gonna start the relay and draining the battery. And in the loop here, this has been implemented so the reading can be taken every second. So it takes the time, current time as millis, so the time since the Arduino started running, and here it updates the previous time to current time. So if the difference between the previous time and the current time is 1 second, is 1000 millisecond, and it has to satisfy these conditions as well. I'm going to explain what they are later. So if this is true, then it's going to go in and start calculating the current values. So it will update every second, and I'm going to show you how the capacity is measured. So once this is satisfied and the voltage value is over 10.5 volt and the relay state is high, so if the circuit is running and the battery is draining and the voltage value is less than 14.5 volts, so there is another failsafe. Say if you disconnect once the program starts and then you disconnect the battery and then connect it to a higher volt battery, it is still gonna save the components, because every time it goes through the loop, it checks the battery voltage level. So it reads the voltage sensor input and the current sensor input, and using the functions explained above, it converts the value to actual voltage value, and it converts the value to an actual current value. So here it's just displays the voltage and the current value to the LCD display. Now this might probably be the most important line in this algorithm. So I'm going to explain what it does. So what it basically does is every second it takes a current value, so which is its ampere second rating, and if I add all the current values over those all the current value over the drainage period, we will have integrated all the current values over the time. So we will end up with in ampere second the amount of capacity that the battery can hold, and if we divide it by 3600, that essentially gives us ampere hour, and then it just displays the capacity on the LCD as well. Now here this is used for Excel data streaming, so I'm gonna explain it in a little bit detail how this function, how this system works. So basically you send any data that is sent through the serial port is gonna show up in the Excel. So it has to be comma separated. So if I set it out the time, so this is the time, current time, and comma voltage value, and it's gonna send on each line, and here is print serial.print line. So on each line it's gonna send the time, comma the voltage value, and also at the end it will send the total capacity as well, which I'll explain a little bit. Now after that, it streams out like I said, it streams out the time and with the comma separated voltage value, so we have a nice voltage curve, and then it updates the previous time, which I already explained. Now at the end, when all those are not satisfied, so the only thing that's gonna change is the voltage threshold. So when the voltage threshold is below, so when the battery voltage is below the voltage threshold, this condition is not going to satisfy, so the code is going to go into the else statement. So here if the voltage value is less or equal to the voltage threshold, then the relay will set it, the relay state will set to low, and we will turn the relay off. So it essentially turns the load off, and this, which was normally closed, if I send a high value to that relay, is gonna open. So the circuit from the battery terminals are open, so no current is gonna flow from the battery through the circuit. And at the end, the capacity value is also logged to the Excel data, Excel sheet. So the last entry of our Excel sheet will be the capacity value. Now I'm going to explain and show the explain sheet as well, and how to configure the Excel. As you can see here, compared to our starting, the battery has drained to around 11.84 volts. So it's the voltage value fluctuates between 11.85 to 11.83. So it's dropped to 11.84 volt, and it will be running. And while it's running, the data is also recording. So we will have a really good battery voltage chart at the end. Now we wait almost 2.5 hours to see the battery, drained battery, and its capacity. Stay tuned. Now a few hours have gone by and the battery has drained fully. So if you look at the LCD screen, you could see that the battery is resting at 4.48 amp hour, and the final voltage is 10.48, which is below 10.5 volt. So the reason we are getting 6.48 is because the battery is a relatively new battery, but it has saw some degradation. That is the reason for the 6.48 amp hour instead of 7.1. And if I now unplug it from the computer, like I explained in the code, that now the only power the Arduino is getting is from the computer. Now if I unplug it from the computer, you will see the Arduino should turn off, and it turned off. So the battery is resting, and it's not supplying any current or any voltage to any of the components.